Well, hey everybody, how are we doing today? We are moving along. This is the last section in Unit 2. And what we've noticed is as we've gone through Unit 2, we've started learning about all these different ways that we can start to tell is something a function and then slowly keep defining it. Not only is it a function, but then what kind of function is it? Is it linear? Is it nonlinear? When is the function increasing? When is it decreasing? When is the function positive? For what values of x is that? When is it negative for what values of x? Talked about y-intercepts and x-intercepts. And then as we started looking at these, hopefully you started realizing that certain key points on a graph help us determine things that we need to know about it. So again, if we want to look over key points, our key points for all graphs are going to be x-intercepts. In other words, we want to know what is the value of x when our y is 0, and that's literally the point where the graph is going to touch your x-axis. Y-intercepts, they want to know, well, what is the value of y when your x is 0? And that's where that line is actually going to touch your y-axis at. When we're dealing with things like increasing and decreasing, we have these areas where the graph turns a corner, where it changes from increasing to decreasing or from decreasing to increasing. These are called either our maximum, our minimum points, and together they're also called extremes. So again, you might also see it as relative maximums, relative minimums. What are your relative extremes? If they ask for maximums, you just want the ones that are at the top of the hill, and the minimums would be the bottom. If they ask for all the extremes, well, you add up how many total changes do you have, and away you go. Now, the concept that I think is the hardest for us to wrap around, which is new this year, is about these positive. When is the positive, the function positive or negative? Meaning, when is the graph above the x-axis? So what values of x is that? And what value of x's are below the x-axis? We have to use our x-intercepts to find these. So that's the key points that relate to positive and negative portions of the graph. When we're dealing with increasing and decreasing, we're using those minimum and maximums, or where does that change occur? Okay, so we have to think about those things as we get into doing these particular problems. Now, as we start in this section, what they're going to be doing is they're going to be giving us key features about the graph, and we have to recreate what it looks like. Knowing not everything, they're not giving us everything, so some of this is up to interpretation depending on what has been given to us. So take a look. This first one in example 1, it says all values of x are positive. So again, when we're dealing with positive next or negative, we're dealing with the x-axis here. So they're telling us that everything in this first graph is going to be above our x-axis. So we don't even need the whole Cartesian plane. We just need quadrants 1 and quadrants 2. Now, what else are we going to be doing here? It's saying when the graph is going to be increasing when x is greater than 1. So let's get some reference points in here. Right? So when our x is 1, in this case here, the graph is increasing in this side. And then it's also going to decrease at 1. So something's happening at 1. So we've got that we've looked at. We have a relative minimum at the coordinate 1, 4. So 1 over 1 up 4. Now we can start to get something going here. And they said from this coordinate, now that we know that this is a minimum value, meaning it's supposed to be the bottom of a change, any number of x that's greater than that, it's going to be increasing. And any number that's less than 1, so less than 1 this way, is going to be decreasing. All right, so think about this graph, right? You're coming down, you're coming down, you're coming down, you're coming down, decreasing, 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 and then suddenly there's a change, and now we're going up again. And it says there is a line of symmetry at the equation x equals 1. So again, lines of symmetry means that this is a symmetrical graph, which it is there. And if we were to create a vertical line, we cross the x-axis, x equals, and where did you cross the x-axis at? 1. So this would be what represents our equation, so to speak. Okay, so again, this is what they gave us. This is all that we can do with this. And we sketched a graph. And if they gave you 4 graphs to pick from, that would be the particular looking graph, a symmetrical graph that has this particular coordinate, 1, 4 as a minimum. And on this side of 1, it's increasing. And on this side, when anything less than 1, it is on that decreasing. All right, there you go. Let's look at the next one. Zoom in on this one a little bit. All right, so it says, oh, they give us a bunch. Now we got minimums, maximums, some areas where graphs are positive, which means there's going to be some negative in there too, probably. And we have end results, like as your graph is going towards negative infinity, your y's are going towards negative infinity. Let's start to see how this looks. This looks like we are going to definitely need to use a whole Cartesian plane. All right. Okay, so we have some key points. Just creating some arcs from my graph. Again, this is not rocket science. We are just sketching. I know I have a minimum at the point 2, 3. So I'm going to go over 1, 2, and up 1, 2, 3. Here's a coordinate right here. And this is a minimum. Minimums mean I'm at the bottom of a U or something here. Then we have what? Maximum at 1, 7. 1, 7. Right? That means maximums is you're at the top of some sort of turn. And I have another maximum at the 0.54. 1, 2, 3, 4, 5, 2, 3, 4. Right here. Again, there's another turn that's happening here. Okay, what else? It says the graph is positive, or the graph is going to be above the x-axis. Positive means above the x-axis. In between the values of -1 and 6. Well, remember up here, what did we say? When graphs are positive or negative, positive means above the x-axis, and we use our x-intercepts to define that area. Well, that's what this is. That's an x-intercept. There's your x-intercept. So we know here's some more key points, our x-intercepts. -1 and 6. Now we're ready to start to connect some of these. We know above our x-axis, it's positive. So it's going up to this point, and then it turns, comes down to a minimum, and then it turns to this next maximum, and then it turns and heads back to there. All we don't know is we just don't know what's happening with the end results, but that's what these are for. So look, as x is going to negative infinity, well, as x, here's the x-axis, is going to negative infinity in this direction, or as our x's are getting smaller, our y's are going to negative infinity, or our y's are getting smaller. So think here's 0. This is on your x-axis. Here's your 0. So where are the numbers smaller at? In this direction. And so we're increasing, increasing, increasing. We have that turn. There's your maximum, turns down to the decrease. It turns, it comes up, it turns, and now we need to figure out where does this go. So this is saying as our x's are approaching or going towards infinity in this direction, or they're getting larger, the y's are going to negative infinity or going down. And there you go, guys. I mean, this obviously is not a highly detailed and defined graph, but you can see from sketching this graph that it's a graph that goes up, crosses the x-axis at -1, has a turn, Comes down, there's a minimum, it has a turn again. It's going up, increasing. Oh, it turns again, decreases, and then goes down in a downward direction forever. Let's look at our last one. Oh, is this, like this one up here was symmetrical? Is this symmetrical? Is there any line we could draw a vertical line, cut it in half, and then like make a mirror image so that one side is exactly the other? No, this is not. There's no way to do that. It's not symmetrical in any way, shape, or form. It is continuous because we made it that way with a solid, nice, smooth line. But it's just something that we did. Okay, notice that was not information given to us, but that is something we can look at. You can tell that just from these key points, you can tell this is not a symmetrical line. And we can look at our last one here. All right, notice doesn't say anything about being positive or negative. We could interpret this when we're done. It says there's no extreme values. Let's see what's happening with this. As we go here, we need some points. See if I can read those little lines for us. All right, so I have an x-intercept at 4, 0. All right, so I have an x-intercept right here. And then I have at the y-intercept, don't move left or right, that's what the 0 means, and -3 tells me to go down 3 units. Here is my y-intercept. I only have 2 points. The only thing I can do with 2 points is I can connect it. Well, it's not a perfectly straight line. Look, that is a line. When all you have is 2 points, there is no extreme values, meaning we can actually go farther in this. We could actually ask ourselves, well, what is this? This is a linear function. This is a line. Why is it a line? There's no extreme values. There's no change. It's increasing the entire time. And if you look really even more right here at 4, when x equals 4, right? Whenever x is greater than 4, the graph is positive. When x is less than 4, the graph is negative. There's more stuff we can pull out of this. It has a constant rate of change. That's what makes this a line. Its rate of change is constant. You can even do the old from pre-algebra, rise over run. Or rise over your run. You could find your slope on this graph, even though it's not perfect, it's close enough. From one point to the next, it's the only points we have that were given to us. You're going up 1, 2, 3. That's your rise. Up is a positive movement. And then to the right, 1, 2, 3, 4. Right there, rise over run, 3/4, positive 3/4. It's a positive slope. You can tell all that stuff from this, right? The graph is, and the graph is being positive because the graph is above the x-axis when x is greater than 4. When x is less than 4, it's below the x-axis. Positive and negative on a graph. There you go, guys. Get into McGraw-Hill today. That's where your homework's at. And start to do your lesson. Last lesson of the section. Next one will be our review for our tests. So have a great one, guys.